So Camille is an assistant professor in the Forest and Rangeland Stewardship Department at Colorado State University with areas of expertise in fire ecology and disturbance ecology. Camille is also the assistant director for ecological research and monitoring at the Colorado Forest Restoration Institute at CSU. And it looks like you are good to go. So thank you, Camille.
Yeah, and you can hear me okay? Maybe.
That's a little better.
Okay. Okay, so I was tasked with kind of starting this workshop off on a very broad scale of thinking about kind of west-wide what we know about tree regeneration, how this plays a role in what we think is going to happen in Colorado after the 2020 fire season, and kind of give some of those uncertainties that I see in it. And so this is definitely like a big view and hopefully sets up the subsequent presenters since it's fairly short and there's a lot I think I could cover on this topic. So right, when we talk about post-fire recovery, these are two different landscapes at about the same time post-fire. One is in Idaho, in the Selway Bitterroot Wilderness, where we see a ton of lodgepole regeneration. The other one is in New Mexico, where we have hardly any tree regeneration in this picture. And I think this is, kind of presents the dichotomy that we're concerned about when we talk about how these landscapes are going to look, at least for the foreseeable future. And I think this kind of starts out with this idea of like the 2020 fire season being unprecedented. And I don't know how many times we can say this same word in, subsequent years, but I think 2020 was definitely that for the fire community as well as in many other ways in our lives. But this is a picture I did not take. It was from the Associated Press of the East Troublesome Fire, I think shortly before it blew over the Continental Divide, which really speaks to how what all of you all and we all were dealing with when these fires were happening. Just these really large events, these wind-driven fires across these very dry forests. And so the question is, like, what do we do now? How do we manage these huge fire footprints that we're now faced with? And I first think that it's important to identify that we are not dealing with the same narrative that we have for our other large fires that we've had here in Colorado. Most of the other large fires in Colorado have really been in this lower forest ecotone, this ponderosa pine to mixed conifer forest. We have these places like the Hayman and even the High Park fire were all in this, or predominantly a lot of the forests that burned were in these kind of lower elevation forest types. And we've gotten really good, as many of you know, at selling this story of these dry forests, lower elevation forests having more frequent fires in the past, and thus these large, high severity catastrophic fires are outside the norm of historic range of variability of what these places looked like or may have burned like in the past. But now this in the 2020 fire season, we really saw fires that spread across this entire range of forest types. We're talking about the Continental Divide up here in this alpine zone. We had, the Cameron Peak fire really started and took off in the subalpine and lodgepole zone. And we also have places like the Pine Gulch fire, which was more in this lower ecotone. And so it's, we're really dealing with a whole bunch of different fire histories, as well as a whole bunch of different fire adaptations for all these different species. And so when we talk about recovery, it's going to look different across this range. And I think that's really important as we kind of move forward in thinking about this recovery process, is that we really need to, focus in on which of these areas we're talking about and the different, kind of dynamics that are playing into those forests. And so here are a couple of pictures of some of those areas that have burned. Here's Marin. I had to, include a picture in the Kelwood fire. looking out at a pretty large high severity patch. This is a patch from the Cameron Peak fire, very close to Cameron Pass. And, again, even though what we're seeing here is all black trees, these are, or predominantly black trees, there's some needles here on these ones. They are really different forest types, even though, and may have very different recovery pathways, even though they all, both of these two areas anyway, burned at high severity. From ponderosa pine, all the way up to, this is kind of on the edge of that lodgepole to spruce fir area. I was actually trying to hunt around for some of Zoe's sites that you'll see, hear her talk about in a little bit on this when we were skiing through this area. And I think the question becomes, right, we have these really large fire footprints, and where should we be concerned? Where do we need to do management actions? And specifically, when and where do we plant trees, right? We all know that planting trees costs a lot of money. It's really time intensive. And we don't want to lose those resources just because they get planted in a place that is either going to recover just fine and we didn't need those trees, or conversely, we don't want to plant them in a place where those planted trees are not going to survive. So I think one of the big things, and I think I spend multiple weeks talking about this, and I'm apparently missing a couple of the pictures on this slide, so maybe let's see if they come up. But species have many different adaptations to how to recover after fires. This picture on the right is a really nice one showing tree regeneration, kind of in front of a ponderosa pine stand or refugia there. Within a burned area, and you can see pretty nice abundant tree regeneration in that case. We also probably are all familiar with oak and aspen and their re-sprouting ability after fire. That's going to look really different, right? We might see, this picture was taken 2 years post-fire after the fire in southern Colorado, and we might see many places with aspen and oak that look like this even next year or this coming year in the 2020 fires. And then I did have a nice picture, and I don't think it's going to come up, of a sea of lodgepole similar to that first picture, which just really is, their adaptations are having some of those serotinous cones, and you could see a really abundant amount of tree regeneration right after a fire. And in fact, I've been to some sites 2 to 3 years post-fire that had 2 million trees per hectare, or about 500,000 trees per acre. And so it's in that place, you definitely don't want to plant because you're already dealing with an overabundance of trees. So I want to talk about a couple cases that may have some relation to what we might see here in Colorado. And one of which is kind of trying to break out these different forest types. So this is a study that looked at tree regeneration across a pretty large area in the Rockies. This is specifically the data from Yellowstone, because I had it split out by different species, or different forest types anyway. And what we're seeing in a lot of places across the Western US is a decline in the amount of tree regeneration that's naturally occurring, in part because of climate change. And this was really dramatic in this study when we compared areas that had burned prior to 2000 to areas that had burned post 2000. And so that's what this is showing. All the 3 bars on the left are those areas that burned before 2000. And you can see that regardless of the forest type, we have pretty good presence of at least one seedling on a site. The dry mixed conifer was where we saw the least amount of tree regeneration, but really across these 3 forest types, we see quite a bit. But then as we move to post 2000, the amount of sites that have no tree, not a single tree on them, go from 28% all the way to 65% for this dry mixed conifer. And it still increases quite a bit from almost to absolutely none of the sites in that moist mixed conifer having no tree regeneration, to about 25% having no tree regeneration. But I think what is particularly interesting here is this lodgepole story. And we're still learning, and I think Chuck will talk about this a little bit, and there's several people working on this already about how the beetle outbreak will interact with tree regeneration post these fires. But at least in these sites, we had no change in the number of sites that had tree regeneration in this time period. So it's coming back great after fires, regardless of those post-fire conditions and those climatic conditions. So that's just something to keep in mind as you prioritize and think about these sites, is that we might have some areas that look pretty good in terms of recovery and regeneration without any intervention. Just to emphasize this point a little bit more about 2000, but also, that we are continuing to deal with these time periods that are increasingly dry and hot. And what that means is that for these tiny trees that are trying to establish, that the probability of trees coming back is slowly going down over time. And this is from a really nice paper by Kimberly Davis and others that showed that before 2000, there was again these like multiple time periods where it was likely that we would see tree regeneration, right? Even some time periods as high as like 65% probability of tree regeneration occurring in that year. Whereas after 2000, this really starts to taper off, and we see very few periods of even like a low probability of tree regeneration happening. And this was focused, I'll stress, on these lower elevation forests. I think this study included just ponderosa pine and Douglas fir. And so, we know pretty well that we're seeing these smaller and smaller windows of potential tree regeneration for these lower elevation forest types. But the story for those higher elevations forests is a little bit different, and we're not quite sure exactly how they are going to recover given these climatic changes. One other thing, here's just one other paper talked about this, lowering probability and increasing likelihood of regeneration failures. And these are just two of the figures from this Littlefield et al. Paper that came out last year. But it's basically talking about that, right, we all experience El Nino and La Nina years, and so there's oscillations of when you'll have great regeneration and when you won't. But as the climate warms, that those oscillations are also kind of decreasing in their likelihood of being great for tree regeneration. And that's kind of what this wavy graph is trying to demonstrate, is that over time we might end up above this threshold where recruitment is possible, even when we think conditions might be favorable. And all of this, I wanted to bring all of those like three relatively complicated graphs into one very simple one. And this is that, right, all trees exist in a certain climate space, right? They have an ideal range of temperature and precipitation and site conditions. And the site conditions and climatic conditions that those trees live in and occur in are different for mature trees than it is for seedlings, right? You can think about a mature tree continuing to exist and kind of survive and eke out an existence even as those conditions get hotter and drier. But those seedlings that are trying to establish are much more limited in their conditions that are likely to occur. And that, is true for no matter what species you are. Where this, ideal sweet spot of precipitation and temperature is obviously varies by species, but we see that, a big bottleneck for tree establishment, whether you're planting them or looking for natural tree regeneration, is in this seedling and early, germinate establishment stage. So I want to, I think one of the big questions that comes up is how this varies across forest type and with different species. And I think some of the next presenters will talk about this a little bit and focus on specific forest types. But again, there is a sweet spot for these trees, and it's, I think, a moving window that we're going to be struggling with trying to capture. especially as we continue to deal with climate change affecting these 2020 fire sites. So I wanted to end with some areas of uncertainty, and there are a bunch, and I'm sure many of you, both researchers and managers, probably have your own enormous list that's much more encompassing than this. But I wanted to highlight a few things that I think we are, all in uncharted territory for. The first is how and where forests may shift with climate change. We have a pretty good sense that we may be losing those lower elevation forests or forest, on the ecotone edge between a grassland or a shrubland and a forest. But we aren't sure how forests may naturally move up the hillside or not, where that needs to be facilitated if we want that to move up and match the climatic conditions, or where it can naturally occur, right? It's very hard to for a seed to fly uphill, so to speak. There's also, a lot of, I think many of you are thinking about or considering how you plant and what species to plant and things like that. And I think there's a lot still unknown about where, this same species may not be viable at that site, or the same species from the same provenance, the same site conditions that are there right now might not work. But maybe, if we're trying to plant in the Cameron Peak fire, getting seed from drier and hotter locations of the same species might work, or even thinking about different species. And, we're really, there's a lot of unknowns in terms of how these trees, what the kind of cold tolerance and site tolerances of a lot of species. And I know there's multiple people on this call working on these specific questions or have as well. I think there's a lot of also, unknowns about soil communities and water dynamics and how that plays a role in the success of planting and natural regeneration, right? Many of you are concerned about what those how those watersheds are going to be affected by these fires. And there's a lot in those regeneration to water dynamic roles that we haven't completely teased out. And then I think something that we're really dealing with a lot with these fires specifically is these compounding disturbances. We all know that many of these fires burned through very large bark beetle outbreaks, both in spruce and lodgepole. And we're still in a kind of unknown phase, and we'll hear a little bit, I think, from two of the presenters on what we do know about these interactions. But there's still a lot to be explored, as well as repeated fires, how these big fire footprints are overlapping. And then I think one of the important things is, right, we're not going to be having probably less fire into the future. And so as we think about planning and facilitating recovery in one way or another, we really need to be also thinking about how that might impact subsequent fires. We are, as we plant, adding fuel to those subsequent fires in some ways. And so we need to be thinking strategically about how we minimize the likelihood or impact on future fires. And I'll just end with this was a really quick rundown of lots of different research, and there's lots more depth and detail that you could go into. And if you have any specific questions, I'm happy to field them. Maren is a great resource, I think, and does really great research on these topics also. And I just wanted to throw out a few other researchers that are doing a lot in this realm as well, though there are many others. So if you have specific questions and you want to email me, feel free, and I can hopefully direct you to somebody who is perhaps more knowledgeable or has a lot more to share about a specific topic. And with that, I will pass it on.
Awesome. Thank you so much, Camille. That was wonderful. And thank you for highlighting those uncertainties. That's really an important set of uncertainties. And I think I agree with you that we all probably have our own list, but I really liked the start of that. So are there any questions for Camille at this point? I didn't see anything in the chat yet. If you do have questions for Camille, feel free to put those in the chat or raise your hand. And then Chuck, while we're doing questions and answers, why don't you go ahead and get your presentation up and shared?
You see that?
Yes.
And you hear me?
Yep.
Cool.
So Camille, I guess I'll ask one quick question, and if no one else has questions for the moment, we can move on. But I'm curious, in your opinion, what you find the most exciting research questions, having been really steeped in this and then just presenting the really great list of uncertainty. What do you think are some of the most exciting questions in your opinion and that are within your area of interest?
Oh, that's such a hard question to answer, especially since I have both current and past students on this call who are working on different parts of those questions. So I don't want to, single out anybody or make anybody feel sad that their project didn't make the top of my list. But I think probably, one of the most exciting things for me is I think about burned areas obviously a lot, but I also think about them as an opportunity for us to really, see how these ecosystems are going to be reorganizing with climate change and with, just these new conditions that we're faced with, both fires and climate. And so I'm really excited, I think, to see how these communities naturally recover. And I think, sometimes I'm saddened by the lack of forests that are coming back. But then I also need to remember that there are some really amazing, whole communities of plants that are there that really deserve a lot of our attention as well. And I think that there's it's an exciting time to think about where these ecosystems are headed into the future.
Awesome. That's great. Thank you. Sorry to put you on the spot. All right.